There we go, that's a start. That's the Motu sorted out. And hello, it's Chris from Airwindows, and we're going to do another coding stream. I know I don't have any viewers right at the moment. That's because as soon as I go live, nobody's actually there. Although I do this on Mondays, so it's possible, oh, there's somebody. It's possible for people to know I'm doing it because I've been doing it this entire time. So let's see, what do we need to do? Well, for starters, let's get the chat window up. Hey. And what we're going to see whether we can do is some coding on what's going to be BrightAmbience3. Because here's the thing, it's probably not going to be too much of a trouble. So this is also a good stream for questions and things. But it was brought to my attention that I'm doing this downsampling stuff. Hey, big music. And BrightAmbience2 is fine, but it does not adapt itself to faster sample rates, so you can still make it do its thing. Here, I'll demonstrate. At least I think I will. Hang on. So we're going to have a look at BrightAmbience2. It's not so recent that it's in recent effects, though. There's some drums. And we've got this echo. And you can stretch it out, because what BrightAmbience does is it uses the sequence of prime numbers to produce an echo that's very kind of gated reverby. And it's not an algorithmic reverb, it's just a raw string of echo samples. But they're spaced in such a way that they work like a reverb. And I got this feedback here, which doesn't seem to be doing diddly squat, I gotta say. I must have dialed it back to the point where it doesn't get too extreme. Don't mind me just playing with this a little bit, familiarizing myself with what we've got. Yeah, clearly that's what it is. Feedback only seems to matter on the lack of length in here. And as soon as this kicks in, we start hearing less and less of that feedback. David, hey. And then as soon as we have an extended length, feedback isn't doing anything anymore. So that might be worth looking into. I see no reason why I can't exaggerate it, and we will indeed talk about the undersampling. That's what I'm going to be doing today. As far as where I get all of the ideas, it's basically my job. Many people know how to program better than me, but my job is basically being able to tap into more ideas on a regular basis, by which I mean weekly. In this instance, it's not a very hard question to answer because BrightAmbience existed before. Let's, here, hang on, I haven't entirely finished setting up. I got my ATEM software control, and there's a macro that I run. put my face in the corner like that, which is what we would like to do. I also have a bunch of experimentation going on as far as cameras and things are concerned. You're not really seeing that very much at the moment, but by next week I ought to have that rolling. I'm getting a kind of a scrim, a kind of a light diffuser, and switching over to a different style of lighting for the videos, and we'll see how that looks. And I'm getting distracted by my image on the screen, as I always do. So let me firstly get out of ATEM and flip this stuff around a little bit so I'm not staring at a moving face. It always makes me stare over here. I need to be looking at the camera. And here we are. So yeah, the reason the sound playback is much more quiet than the mic is because this is going through my speakers. And I haven't really turned them up very much, so I'll be cranking them up a little bit to fit better when I'm actually doing work with them. As far as the undersampling technique, let's start stepping through some of this stuff. Hello, Xcode. We're going to be spending our time in Xcode today. And the BrightAmbience is not the newest of plugins. So some of what this is about is finding things, like for instance, I'll open the first BrightAmbience and then also the second one, and then we'll be doing the third one, and we can talk about what changed each step of the way. Because the goal is to get it to where something really cool is happening, and if you step in without following the process, it would seem like a very startling development. But there is a connection among these things as we go. And the trick there, and one of the reasons why I often run out of words doing these streams, because I'm literally doing the work of I wonder where you get all the ideas on camera. That's what I've been doing on Mondays, and I have been pushing it to the point where like all of my plugin work is done where you can watch it, excepting the porting stuff to VST and all the signed stuff. And that's sort of busy work, so I'm not really doing that on camera. You can see when I run out of words, like I'm working on something. Here is, for instance, BrightAmbience, and we can look at the code here. And this code has a number of things going on, but it's the same basic thing. It's doing this buffer. At the time, this was a double buffer, which is a technique out of some old 2D video games. And you got this thing called switch, which is adding large numbers of delay taps and kind of doing them in goes. There's a particular thing with the switch here, which is that this switch is lacking a break statement, and that's not normal. I'm doing that on purpose because I have a thing I do with it. Normally, if you have a switch statement, it will say various things, and then it will say break at the end, and it will jump to the end of the switch statement and skip over all the other options. But what I'm doing is using it as a way of tapping into the middle of a really big pile of operations. So if you go to 32, it does this, and then it continues onwards and does everything in 31 and 30 and so forth. So if you have a switch statement here, CPU, it says, and you go to like case 8, you're skipping all this stuff above and doing everything from here on in. And these are shorter and shorter delays. So the basic gist of it is these are just previously worked out prime numbers. And it's nothing but an enormous pile of delay returns. It's just one after the other. and they're spaced out according to the samples. Here, I can show you that one. I believe I have that handy. Turn the amplification up to 40 so that you can hear it a little better. And if I show this, see, this is a very early one, so it's set up kind of weirdly. I think decay is some kind of, or not. Oh, I remember what decay is. I completely changed this around. So this is sustain. Sustain is mapped to that CPU thing. So this is as long as this one can go at 96K. If you shorten it, it's got a much smaller set of samples, but they're still basically the same thing. And decay is actually turning down the longest samples, if I'm not mistaken. So it makes it resemble a real reverb a little bit more. Or makes it almost have nothing in the reverb. Now when we load up BrightAmbience3, very different arrangement. But there are some similarities. Like start is where the first delay return hits, length is where the last delay return hits. Feedback only kind of matters for immediate echoes, which I'm going to work on. And of course dry wet is just dry wet. And yeah, Bo, take care of yourself. I got very sick a little over a year ago, which wasn't necessarily COVID. There apparently was another nasty flu going around at the time. And yeah, take care of yourself, Bo. This is not stuff to mess around with. Aaron has a question. There are still plugins. In fact, I have them showing on my screen. Or would if Xcode wasn't covering them. There are still plugins like these ones down here, and various, like this big amp, fire amp, grind amp, lead amp, little amp, and mid amp. I haven't ported those. Melt and tape wobble and circuit bend are in the process of being invented. Phase was going to be made out of multiple instances of phase nudge, but honestly I can do a better phase shifter through the X notch filter, so that's probably worth looking into. Cab SVT, cabs, acoustic bass, these are still sitting around. I have not ported those yet. They're honestly not as good as the things I'm doing at the moment. But yeah, what I'm doing is I'm coding BrightAmbience3, because here's the thing. I can, let's use Alien Kittens to demonstrate it. I think that'll work. I have it in all tempos. I can do BrightAmbience2. And that has a certain length of delay time. And then if I do the 192K, I'm told that this does not sound the same, which I believe because I haven't really done that much to adapt it. Yeah, you can plainly hear the delay, length, and texture are very different. So we're not getting the amount of sustain because it's at too high of a sample rate. The amplitude also seems different, a lot of stuff like that. So this is a fine candidate for applying the downsampling, and this is my cue to explain what that is. Let's get back into Xcode. As you can see, the first Bright Ambience was a strange beast that I made a long time ago. And BrightAmbience3 is more sophisticated. It's kind of this stuff, I've been having an interesting time myself. My experience in post-vaccination, working through the year lost to COVID thing, is I've recently gotten in touch with family members, which has its own challenges. Anybody who has conversation about challenges with family members, I am a welcoming ear, because I'm old enough to have gone through a lot of these things, but have seen my own kinds of challenges. At the moment, I'm looking to get in touch with my two brothers and one sister individually rather than trying to get in touch with them all together. And part of that is because when they get in touch all together, we just jump into the old family roles, and that's proving to be not acceptable to me anymore. That the reason I ended up being Chris from Airwindows and living a very complicated life was, look up the term identified patient. I was always the weirdo of the family, and that has certain sort of obligations and expectations to it, and sometimes they're contradicted by reality, and sometimes not so much. So I told all of them I was kind of dreading getting in touch with them again, because I've had a year of not dealing with any of that family stuff, and I was looking to get in touch with each of them individually and try to negotiate something that was a little different. And the guy who is largely responsible for helping me get together the Windows and Linux VST stuff, my brother Dan, we don't agree politically. There are some things I will not take from him, but at the same time, he has tried harder than practically anybody to work out who I actually am as an adult and learn about that. As far as listening to who you actually are, Dan's kind of among the best. And that's interesting. I'm pretty sure that none of them actually listen to my videos. Like, my sister's husband is the only one who even liked anything that I ever posted on Facebook. Part of the family thing is that they will not look into anything I do for, I don't know, for fear that it'll turn out to be actually good or something. I don't know. But although Dan will not touch any of this kind of stuff or look at it, he helped me quite a bit, and I can communicate with him even though we don't agree on many, many things. I'm still waiting to hear back from him, because when I told him that I was kind of dreading getting in touch with him again, he understood immediately what that meant. And he's going to have to be brave about it, because honestly, I think I can actually work out that we will end up getting together, talking tech and computers and connecting on the levels that we can connect. And we'll see where that goes, honestly. It'll be interesting. He'll be like the only person left who's a right-winger type dude in my life. Everybody else has ditched me or been ditched or thrown some kind of fit or just gone in a direction that I super couldn't follow. And I'm not sure that's true of my brother. If he does, then that'll be sad and that'll be how it goes. But I'm not... There are many questions. You know, the other one immediately assumed that what I meant was that I was cowering in fear from wanting to not get infected with COVID again, and that it was about reassuring like the terribly broken Chris who isn't capable of anything. And I didn't like how that felt, so I don't know where that's going. But he was not offended at the idea that I was dreading getting in touch with him, because the things that I was dreading were so dominating the way he saw stuff that he didn't see any other explanation other than, oh, about COVID, and he's cowering in fear from stuff, and no. And then my sister is cool. She was actually in Asheville, I think Asheville, North Carolina, if I'm not mistaken, on a vacation with her family, and ran into the Moog Museum and grabbed some pictures and got back to me like, oh yeah, whenever you're ready. And hey, I was here and thought of you. I bet you'd enjoy this museum. And I was like, yeah, oh yeah, I would like that museum a lot. So, so that has been dominating my attention for the last weekend or so. But I managed to post a plugin. I managed to post Air2, and I didn't get too physically ill over all the stress of dealing with this family stuff. You gotta watch out for that kind of thing. Family can be your most solid resource or your most solid anchor, depending upon who you are and what you as a person mean in the context of whatever family it is that you've got. And I think people are going to be experiencing that more and more. I think that's why a lot of people, abuse drugs and alcohol or wind up getting all toxic and stuff. It's very complicated. Chad has gone kind of silent listening to me talk about this stuff. But we'll get back to the coding stuff, I promise. So one of the things I was going to say, and I think that this doesn't actually show you my entire screen properly, so let me duck that over. I think you can see everything now. So as far as where do you get the ideas and how they evolve in things, this is BrightAmbience3. It's the most recent one. And in this one, I kind of evolved it. It's pretty simple. And it's using an interesting thing that I did not have in previous versions, where I am making, and it appears that this is one of my stereo plugins, which will make the porting to VST easier. And that suits me fine. But this is a string of prime numbers that go for about 500 instances, because modern computers can do more of this kind of stuff. In fact, even the old laptop that I'm coding this on is able to handle it. And it's going prime for lefts and rights this far. It's a very long line of code. Just goes out forever. And that is the delay time at 44.1K of that original echo there. And the way it works is it'll start at whatever the initial echo is and go to whatever the length is, which is the initial plus whatever else there is. So we have this, which is looking up numbers according to whatever the array number is. Like if you look up prime L, I think it starts from 0. Yeah, arrays start from 0 and C. So if you looked up prime L number 0, it would be 5. 1, 2, 3, 4. If you looked up prime L5, it would be 41. If you looked up prime R5, it would be 43. And this is being used to delay the echoes in a slightly scattered way so that there is a stereo effect that builds up. I think as you keep going, there are times when it's a larger number. I'm not sure though. I think sometimes the delay is only on the order of like 10 samples or so. That will cut. Oh, if you want to talk about plugin ideas, this is the place to do it, because there's more than one person here who programs things. So talk about your plugin ideas in chat so that other people in chat can both talk about them, and you might find somebody else here coding it before I do. And you might end up picking up the abilities to code stuff through hanging out in chat and paying attention to this. So yeah, I'm going to be wanting to look at feedback. And the way this works is the idea for BrightAmbience3 being different was, can I take this? It's clearly a stereo plugin, and instantiate the stuff here. This is the delay buffer that we're using. It goes this long. And we got our start and length. Both of those go pretty nearly to the maximum range of it. The maximum range appears to be around 488. So if you make a maximum length, it will start pushing the start time back. And then feedback amount is for some reason not actually, hey bro, not actually sustaining very much. On our longer duration things. So the way this works is this is one of your delay buffers. It's doing this thing called gcount and defining a thing using that. I don't remember exactly why I'm doing it specifically this way, but I think we can live with keeping it. Adding the new sample plus some feedback, and interestingly, we are assigning that, which might not necessarily be what we want to keep. Then we're building this. This says offset equals start, offsets less than start plus length, and offset plus plus. So this is counting from the first one that we use to the last one that we use. And it's doing this. It's taking the temporary variable and doing the echo. It's adding this. And then it is, this is the way it wraps, basically. And it looks a little complicated because here's the thing. We always add count plus prime L something. As it happens, prime L offset is, so I'm still working on how this works. Count prime L offset. Offset could be just about, it's going to be within the range. We're adding one and then subtracting one. Oh, and I see what happened. So here's the deal. I'm looking at this and it says, okay, count L plus prime L offset and so on and so forth. So our delay time is actually in here. It's this PL and PR, and that is 32,000 samples long. Now, when I go, are we delaying this by prime L offset? Well, we're never actually using the prime L offset, which is some kind of prime number like 41 or something. What's going on is we're walking through this long buffer over and over again. Then we're doing all of these additions and we're adding other samples. We're going, let's see, where do we do gcount? Gcount minus minus. So we're going backwards through everything. And that means that we're adding a new sample where we're at, and then almost immediately hitting the delay points that we come to, like make a noise and then echo it. And it's this densely packed series of delays that we're going through as we hit those. And that is count plus prime L offset, which might be 41 or something, 375. It wouldn't be 375 because that's divisible. It's a prime number. So everything inside here is just there to work out what the offset in our delay buffer is. It looks more complicated rather than just being like PL count or PL count plus 105 for a delay of 105 samples. Because this is not only doing a prime number, looking up in that other array. Prime L offset is the instance in the other array, like the 37th prime number is going to be some number like that, so prime L 37 is going to be another number that's longer. Then we also minus this. And this part is a logic statement. So what it says is same thing as here. This is whatever our number is. Say we're doing count, and count is 32765, right? So if we add 32765 plus some large prime number to make a delay, that's going to be past the bounds of our buffer. So what do we do about that? We check it. And if count plus whatever the prime number is does turn out to be larger than that, oh hey, we are going to subtract something. What will it be? Well, we're subtracting either (32768) to wrap it back around to the beginning again, because this whole thing kind of loops, or we're subtracting 0. We're not doing anything. And that's what this complicated pile of stuff works out, is this is directing us to a sample delay position all within this stuff, and that's all this does. So that is seemingly a lot more complicated than the piles and piles of just raw addition that I did the first time around, but it's more flexible. And on modern CPUs, this is not actually any slower. And that's something I learned from Dan, is that you can't just go as if you're compiling an assembly language on an Apple II or something like that. This modern stuff can do a whole bunch of calculations and things. And the real bottleneck tends to be memory. So I always used to do it so that if you had a delay, like for instance, G count 32767, I would have the actual bounds of the delay be twice as long. And you'd put your the new sample coming in twice. One in the main part of the loop, and then one in this extended part. And you'd just be placing values in these two places. And then you could just do your calculation of like, here's where my initial thing is, we're moving through it so we get a delay. And you could add anything up to the full length of the smaller loop inside, space it out into this other section, which is a double buffer, and it ends up being the same thing. So in really primitive old computers, that worked to be way faster than checking and being like, oh, by the way, if this thing that we added to the delay makes it go off the end of the loop, subtract this to make it be smaller again so that you have the real loop. Well, if you make the Patreon $5,000 a month, you'll be seeing those SP1200s in emulation a lot faster. That's primarily the thing at this point. Like, I'm not particularly worried about paying my mortgage or anything like that, or even, having cameras and lights and stuff to work with. Although I'm pretty good at figuring out clever things to do with things like lights. I don't necessarily have to run around buying expensive lights. Some of that stuff I've gotten pretty good at. But the deal with that double buffering thing is that in really primitive systems where it'll cost you a lot to do the whole calculation twice and then subtract something from it if it went over the edge, it would be faster to just look up something from a buffer twice as wide as you needed, Memory access is more expensive these days, but the calculations are cheaper. So we do this. Instead of just looking up a single number and having that be the cheap way, we're doing this loop, which has a whole extra variable in here, offset, and then we're using that to repetitively run this calculation in order to look up a place in the delay loop that we're using. And the whole point of the delay loop is that we don't actually have to do the really dumb thing of a bucket brigade. Bucket brigade is what you have in analog delays and stuff. And that basically means, sure, you can have a delay. You just, every cycle, you take each one and assign it to the next one and go on. And at that point, you do have a neat little delay, but for like thousands and thousands of samples, it starts to get really cumbersome. So yeah. I'm having a bit of a look at chat at the moment. Most of the stuff that I'm doing is strictly living within C. I don't really make any use of C++ things. Fairly often I don't understand them. There are things I could still learn as far as that's concerned. I'm not super anxious about it because C++ can easily get into stuff that's not great for audio coding or real-time work. But that's generally the area you'll be interested in if you're talking about plugin coding. It generally works in C++, and in practice, most of the stuff you'll be thinking about lives in C. Certainly, whenever I'm doing stuff that is really more CPU efficient than other people's things, it's probably because I'm doing stuff in C rather than getting real sophisticated with C++. C++ builds into being able to do programmer elegance, kind of similar to what I'm doing here. There's aspects of elegance that I can make use of. Like I'm doing this rather than doing some enormous select case statement and having all of these values hard-coded so that I can do them in the most primitive way possible. But when you get into C++, you can do all manner of things like, okay, let me invent a class for doing delay buffers and have it overloaded so that it instantiates new forms of things. And then you can add other features to it by making subclasses that can connect to the other. It's like you can get really fancy with some of that stuff. And there is an aesthetic to it for programmers, but I don't think it helps musicians any. You know how my like catchphrase is, in mix no one can see your screen? Well, after you compile, nobody can see how clever the code was, except for that your program is 5 times larger and doesn't run very fast. That's how people can see how clever your code is you were able to do a really elaborate thing in about half a screen's worth of code of interlinking classes and all manner of other things. And then when the program actually runs, it really kind of has to jump through hoops, and it takes a long time and uses a lot of energy and space and blah, blah, blah. So speaking of energy and space, this is pretty much the entire size of the new BrightAmbience. This is the actual code that does things, and the part I was showing you is the guts of that, really. So what we're going to do is look at, first of all, I want to see how I can get the feedback to work more interestingly in long delays. It does not impress me that the feedback was only working for basically slap echo. So I'll be having a look at that. But more importantly, it is time for us to include the undersampling so that I can run it like 192K if I wanted and still have the same delay buffer. And it'll also give it its own like useful kind of tonality. Because one of the things about BrightAmbience is using primes like that gives you a sound that technically acts like a reverb and doesn't have nasty rings and reinforcements in the tonality. But when you use prime number delay taps like that, although it's effectively colorless as far as the tone is concerned, there's a super high frequency emphasis. The way that the prime numbers like interact with each other, it's so dense. And remember how I did chamber, where we did chamber live on stream and discovered that the Fibonacci series ends up being like a golden ratio, and then I just ran with the golden ratio stuff. And that produced a reverb where it's not anything like the sequence of prime numbers. Instead of being a smooth, featureless spread, it became this choppy, echoey, sputtery thing, and then it smoothed out because that's the way that the golden ratio stuff interacted with copies of itself. What we've got here is not like that. In fact, it's possible if we start putting in the feedback, we'll end up getting stuff that does nasty high frequency interactions. But that's fun in its own way. But the thing about doing the undersampling, and say if we're at 192K, we're only doing this stuff every 4 samples, and then we're interpolating everything else. I can use the darkening code that I've got, the averaging thing that I tucked onto the back of the undersampling code, to handle bright ambience in such a way that it smooths itself out. And that'll make the higher sample rate stuff have a sort of more vibey, reverby effect rather than sounding really DAW-like and artificial. And I think that'll be worth doing. So next order of business is we're going to, clearly I've been talking a lot because it's getting on towards noon now. We should be able to get through this though, I promise. We'll have something up and running. We might even get it entirely done. The way my templates work, I'm selecting with CocoView because that's where I put the what you see here. That being the code. This is the initial source code. For the stereo plugins. So the way I've got my templates arranged, if I choose not to do the CocoView, it gives me a mono end-to-end plugin. And if I ask for the CocoView one, rather than doing the one that has like AU style GUI that I never actually worked out, honestly, it's not worth doing at this point, because at this point, according to the Surge synthesizer guys, if you want to get into doing GUI cross-platform for things, then you probably should just use Juice. And I don't know C++ well enough to be able to do Juice. But if I was to learn something at this point, I'm committed that it would be that. Because the Surge folks are way better at that stuff than me, and they're really into it. They really, really like Juice, so fair enough then. Also, if I was to learn to do things like VST GUI, which the Surge synthesizer folks hated, or the core audio with interface builder and whatever that is, those don't adapt to each other. Like the core audio stuff doesn't adapt to any other form of plugin making. And in fact, some folks had real problems doing it. I remember specifically Massey with Tapehead had a preliminary version of Tapehead that he was trying to get together in the Apple way with the Core Audio and the Coco builds and stuff, and he was having a hell of a time with it. It's apparently not very well sorted out. He was running into major problems. And so I never got into it. I've just been doing generic stuff this entire time. And now, if you were to get into something like that, again, it sounds like Juice is the way to go. Oh, hello, Xcode quit unexpectedly? Well, I don't like that. It's usually pretty good about not doing that. Let's open it back up again. There's BrightAmbience3 again. And let's also, oh no, hang on. That's not what I wanted. And let's also open up BrightAmbience2, start walking through the porting form of it. Oh, Periska. I would note, iPlug2 is from the guy that helped me start getting the signed plugins built together. I hired that guy for 2 entire days, one for the AU and one for the VST, although I'd already gotten a bit of a start. Yeah, that's the reason I keep going on about Juice is not because iPlug2 is not good, but because the Surge synthesizer people are good and did like it. I'm actually supporting the iPlug2 guys' Patreon and not supporting Juice. But that's the one that, honestly, maybe I should have them have a look at iPlug2, see what it's like. Ole Larkin is a smart dude. So that's worth mentioning. But I think maybe part of the reason he's doing it is because Juice has become so dominant. I know the reason I was interested in looking into it was because it was way simpler. Juice is such a big pile of everything. It tries to do everything. That part I don't like. That part the Surge synthesizer folks loved like crazy because they love including all the features everywhere. and they're including my plugins and everything. But yeah, honestly, I would say that if I understood it, iPlug2 would probably be more my style than Juice. But none of these GUI things are really my style because they're all based in C++. They're all based on stuff that I didn't go to school for. I didn't go to programming school, so go figure. Anyways, let us start walking through this, assuming that Xcode doesn't simply crash. Hopefully it won't. And if we copy some of these things over properly, so BrightAmbience1 was apparently BRAB, because BrightAmbience2 is BRAC. So BRAD. BrightAmbience3 is named Brad, apparently. And that is our comp subtype. That's our ID number. It'll also show up in the VST plugin. That's how the program looks it up. It doesn't look it up by the name of the effect, it looks it up by this code number. Oh, I'm sure Juice has a kitchen sink too at this point. At some point, I'll get somebody to do me up a probably strictly for the modern world things. Like now that we've gotten into signed Mac plugins for AU and VST, that is the platform upon which I could probably also get Juice builds going, but I wouldn't be able to make them port back to the older stuff. So I'd always have to be doing stuff that started out as generic interfaces, but if I had things like dedicated meters in mind, and I do have some ideas for that, if I was doing that, then I would need to have somebody, like the Surge guys would probably be more than willing to do that for me. So if I give them enough more plugins to enjoy. Anyways, somebody there would probably be willing to walk me through getting a Juice build set up and kind of the way that works when I'm doing something with somebody is if I have the vision for what it's supposed to do, but it's all C++ and Juice and I don't understand any of it, I basically have people do my work for me. And I'm playing like the Steve Jobs role, which is like, no, it should be this. And that's deeply obnoxious. So I don't get myself into that situation very often because I have there's a limited amount I want to be deeply obnoxious, even for a good cause. And getting like an amazing Airwindows meter plugin that worked for signed Mac AU and signed, it would go back to whatever the limit on Juice was. And it's just a matter of like, how worth it is it to get somebody's cooperation so that I can basically flog them through doing all the busy work of this while telling them exactly how it has to go. That's kind of mean. I'd rather work with people and have them get a lot of input, but that is not always how that works out. And so what we're doing today is not that. Instead, it's stuff that I can do entirely on my own hook. Oh, cool. I'm pleased to hear that iPlug2 is getting KVR Developer Challenge stuff, because I like that guy, Oli Larkin. If you want to support plugin makers and things, and you like iPlug2, he has a Patreon too, I'm supporting his Patreon. So it's worth thinking about if you like that. Damn if I know, Bishop Mikhail. I'm sure somebody else could. I don't know anything about AUv3. You would want to start with the the signed AU builds, which are in a modern version of Xcode. Those are probably not that hard to adapt to AUv3. I simply don't use AUv3 and have never worked with it at all. So I don't even know how that would. Pitch shifting plugin or shimmer reverb. Well, look at Glitch Shifter and also Triple Spread. I've got a variety of pitch shifters, but they tend to be unusual. I actually have another one in mind because there is a type of pitch shifting that existed on old samplers that would be very easy for me to do. And it's essentially a really naive pitch shifting algorithm. Some of these folks talk about that. It would be a pretty good choice for doing in a undersampling technology, because you could undersample it even more perhaps. But this pitch shifting thing I'm talking about, you're basically running a little delay loop, and then rather than having it be only a delay, you're making the delay tap go at a different speed from the right tap. Like there's a delay head and a right head, but they're going in different places. You can even do this in analog, believe it or not, but it sounds kind of weird. It's something that you can do with tape in a limited sense. But what Glitch Shifter does is it tries to find places to cross over where the waveforms line up. So it tries to switch over in a clean way rather than making crackling noises and stuff. And that limits the tightness of the loop very much. In order to get a really smooth pitch shift in Glitch Shifter, you have to loosen the tracking enormously. I've never made a format filter. And normally what you do is you have a tight little delay loop, and the entire delay tap is sort of one big crossfade. It's spinning around in this loop, and the playback head is going at a different speed, so you get a different delay time. And then when it needs to switch, it's been crossfading the entire time. That's very good at not having an obvious ringing noise, but it's also very good at blurring everything out enormously. And these really primitive old pitch shifters on the samplers don't do the crossfading. So when you fool with them in a really tight little delay loop, they have this loud, grindy honk to them. It's a really gritty, nasty thing. And some of the folks who like these old things sometimes really get into that. So I need to do a plugin like that. Chat. Let's see now. As far as shimmer reverb, somebody is already asking me for a version of Chamber that has pitch shifting. The feed-forward reverbs haven't been using pitch shifting because they're based in a sort of Bricasti style ethos, and hence the combination of feed-forward and feedback. And that's been working out gangbusters, but in the process of doing that, I've also embraced the Bricasti thing of not wanting to have any pitch shifting ever, which is fine, but I could, so we'll see. We'll see. A shimmer reverb, what that is essentially have your reverb, and then for your classic shimmer, what you've got is a frequency doubler. So you have a more artificial sound, but it's an octave up. And that can be done in a number of ways. But you can also do crazy reverbs. For instance, the Sean Costello of Valhalla has done a lot of wonderful things as far as making crazy reverbs where you can do weird pitch bends and things in them. And that's always fun. It's not very convincing necessarily, but it's an effect. It's a very colorful effect. By the way, I'm not sure what a Pasola and Wissola are. You can explain that also. DBX165A, that'd be a compressor of some kind. Rat-based, well, I do have a rat-based stomp box. I do have one of those. I don't have a Boss BD2. I haven't actually explored the stomp box just because honestly, distortion is where digital is the worst. So there's a limit to how much I've done with that, and there's a limit to how much usefulness I can get out of stuff that's actually modeling something like a rat. A rat's a op-amp based diode clipping type thing. And diode clipping is a pretty hard clip. Not ultimately hard, depending upon the diodes you're using. Each different diode is going to have a different breakdown behavior. But super hard clips are not where digital sounds its best. So doing a rat, I would more argue like get a rat and then run your guitar through that, sample it, and then do other stuff in the box, but find yourself a real rat to work with if you want to do that. We shall see. I've got a variety of different things going on. Math needed for low-level DSP things. Well, we'll try to talk about some of that today when I actually get into doing more of this work. Although I gotta say, it's good chatting away about it. That's always good. So here's where we're going to live for a bit. As soon as I change the size of this window properly. Because it doesn't matter how wide I'd make it, it still wouldn't include that stuff. It's just too much of it. So we will start by copying some of this over while leaving the other stuff, just so that I can fool around with things if there's more things I'd like to fool around with. This is always my practice doing a new plugin, is leave the massive list in my template so that I have more controls I can throw in to experiment with. Same with this enum, it's going to be the full size. And then what I've got here is this definition of what these arrays are. And I'm putting the values in them as they are being made. Static means you don't get to change this ever. And it also, in the compiler, can sometimes work with it faster if it knows that it's static. There are subtleties around that. some of which I haven't really known all that much about, but I do try to learn at times. And here's one, the static int arrays, and we're just defining this as a sort of lookup table. In fact, that's exactly what it is. If you want to get into coding effects as a hobby, what you should do is do whatever you need to do in order to get something that builds, like a gain plugin. I'll show you what my template looks like. I've got templates. If you can make them work for you, then that is good. I'm going to take a moment firstly and copy this stuff over, and then I'll show you what the template looks like. Oh, hang on. No special reason to do that. Actually, I think I got that kind of mixed up. That's more like what it should be. The spacing doesn't actually matter. Ooh, Faust is very interesting. I'll talk about Faust a little bit. So let's see, learning math for low-level DSP things. I have established this stuff, so now we're going to go over to here. And while talking about it, I also have to do the actual work involved, so bear with me. This stuff isn't going to be changed. This is going to be built into the template, and this needs to be put into my new one. So that's there, ready to be used. And this is slightly different from what I had before, because the previous one wasn't actually set up as thoroughly as the current one is. This is an older plugin, BrightAmbience, and this has the same starting random number for all the different plugins that get instantiated. I improved on that. Also, this is a mono. It's a, well, no, it's not, is it? So I guess this isn't really truly random numbers for each side either. But this, all the randomness is improved in the new version. This kind of gets us over to what we were talking about. Yeah. Faust, I discovered when I first visited the Surge Synthesizer Discord. And somebody there, I was pitching an idea for something that would be cool to do as an oscillator. And the guy's like, oh, like this? Here, let me put something together in Faust. And he jumped on an online web program. It was a web page that you could live compile Faust and plug a MIDI keyboard into the computer and play stuff over this web page. So you can write oscillators on a web page. There's a Faust-oriented web page that lets you do it. And that was super impressive to me. And yeah, you can compile, you can get code out of it. But what was really impressive was that you could code together the oscillator or whatever it is that you were doing with it. Like I was able to do the idea I was pitching to people in Faust, and then the other fellow coded it together, and since it was in a working state, I could see the things that could change and go like, okay, well, let me do this, and now let me do this, and now let me do this, and very quickly I had a very neat oscillator with a distinctive sound that didn't exist before then. It was kind of insanely easier. Certainly as far as like trial and error, trying stuff out and then trying to play it with the keyboard and see what it does. I think that's the fastest way to learn. As far as being a fast code to go in plugins and things, it compiles to things like C++, so that might be some kind of fast, but I'm not sure that the sort of interpreted Faust is necessarily CPU efficient. It's just incredibly fast to work with. So let's see now. So I've just instantiated this stuff. The only thing that is remaining is to copy over the actual code from here. Also the instructions from here. That being what we're doing with the controls. This is the audio code, and this is what tells the audio code what to do. But we haven't done that yet. So the question was, how do you start with the DSP stuff? And what's a good place to start? And I mentioned, do something that is like a gain plugin that compiles and runs. So, firstly, supposing you didn't have any of these controls, because we're going to be putting them in elsewhere. Supposing we didn't have this, because we're not going to be using that either. Or indeed the dry wet. And that means I could delete this as well. Let's do my. I had somebody who was posting issues on my GitHub and stuff, and they were saying like, oh yeah, I'm able to get the plugins to run as much as 50% faster by making everything be forced to be float. Cool, do that. That's never going to get into an Airwindows plugin, because the whole point of my running the longer sample bus and doing the dithering to floating point is that I make the calculations at a lot higher resolution than that. That is how the sound is got. But yeah, you can do many things and run them faster with more primitive data words. So what you're seeing is a gain plugin. And this is where you start. This is where you start with your DSP. You have your gain variable. And this basically just doesn't run the calculation if it's going to amount to supposedly unity gain. And I do that because if you multiply floating point numbers by a floating point number where this is where the floating point is, it forces the floating point of the result to be in a place that will accommodate both. And if it can't, it'll pick probably the largest one. So that's why I do this stuff. But mostly what you'll have is just that. So if you were going to make it be a, I don't know, a mid plugin, you're going to make a mono plugin. You want it to be both exactly the same. Instead of having that, you could do like assigning that to gain, and then see, that's interesting. Hitting the colon there was a C++ feature, which I do not intend to use. It did things to the indentation. If you wanted a mono plugin, you could do this. And then each channel would be both of the channels added together and then multiplied by 0.5, which is the same as dividing by 2, so that you get back to the original volume again. Because otherwise, each of your channels would have both of the channels added together, and it would be twice as loud. Hey, be music. Fair enough. Yep, I do long double on purpose. But yeah, absolutely do stuff as doubles. Doubles would probably do you for pretty much everything, including biquads. It's overkill because it's like, well, I don't have to use the CPU of an interface, so I will use the CPU for audio qualities. And float is where you're going to start getting into old school digital sounds. It's going to be a little flatter. Float is where we get into the whole dithering to floating point, because we're basically dithering to floats. See? All of our audio is actually float 32. That is the same thing as floats. And the reason we do this is because if you stack up enough plugins, you do wind up seeing the end result being the principle of dither float is that when you're doing this too much, the loud side of your audio samples are what's going to get crunchy. It'll scale down to quietness as good as you could possibly want, but you're still going to erode things through truncation, through repeatedly going to floats and doing all your audio processing there. So would not be advocating doing that, honestly. Let's get into this part. This is going to be looking the same. We're going to be wanting to use overall scale later, although it's not being used at the moment. And we're going to take this without actually rehacking it yet, and straight up copy it over. Instead of that floating point dither, we're going to be having our newer floating point dither and our newer, no, I think that might be the newest. Let's go, let's just do it. Getting into that trouble with speaking zone. So at this stage, I can close BrightAmbience3 because we're not going to be using it anymore. And everything else is done. So we're going to do the traditional try to build it once and fail. And the reason for that is this particular template tries to build the code before it builds the support stuff. I'm pretty sure it's doing it like top down. So it hasn't built AU public yet. We build it again, and this time it's fine. So we should have a copy of BrightAmbience now. We'll go into the build folder, and we're going to work out that it is, I don't need to put it on top of the audio files, let's put it here instead. Yep, my hope, Matteo Stanisi, is that I can do BrightAmbience3 to be an even better secret weapon, especially for people who are running at the higher sample rates that I advocate. I know that is not the most common thing in the world, but I should also be able to bring some useful things to the new version. And here we have it. So this is running at 96K, so this is half the length. You can put a little pre-delay in. Almost no pre-delay to and of course, with no length, we have the full feedback effect. But as soon as we start increasing length, we lose that. And I don't think that was intentional. I think that's just how it worked out last time. It's not continuing to sustain. So here we go. Time to dive into DSP land. And firstly, let's figure out what happened with that, because that is something that I would like to have available to play with. We can probably do some of this stuff fairly quickly because all of this is now functioning. This is the same as we had in BrightAmbience2. So firstly, let's see whether we can get, well, for one, let's exaggerate this even farther. We do have to have a total limit on that, so we'll make the start and length go to pretty much the whole range of how far this can go. Feedback amount seems to be fine, and it's not being adjusted by starter length here. Instead, it is going up to basically 1, and if I have virtually no width of this window of samples, we're getting full feedback, or at least very nearly full feedback. This part seems normal enough. I'm not sure whether it's doing a crossover. Feedback A. It is doing a crossover. Well, that's interesting. I don't know whether that's what we're going to want to do or not, but certainly I think that can be done. So, let's see, because here we're entirely replacing input sample with this delayed stuff. We have a temp L and a temp R. Which is defined up here, as it should be. I'm going to move some of this stuff around just because. As far as aesthetic is concerned, I like having stuff in visual blocks, and I'm not all that concerned about having like a statement on one line all the time. But I want things that do a particular thing, like this is doing the timing of the loop. It's cycling through the loop. So that's what this stuff is doing. And then this is assigning that, putting our new audio into the loop as it goes. And then this is all about getting the audio out. And then we entirely replace the input sample with that. But we still have these. So what would happen? Because you see, length is scaling back how loud it is. Jas, yeah, I guess you are a mad lad to be doing that. And some of that stuff, it's not going to help you. It depends. Like, you can do that with lots of distortion plugins, and it'll probably work out just fine. Other stuff, it's not going to be beneficial at all. So let's see now. Here's a question. If we put the raw temp in here instead of the input sample has just become the same thing as this but turned down. It's divided by square root of length. So what we're doing is taking the audio, and when it's a really long delay, we just keep turning it down. Square root of length could be divided by quite a large number, although if it was divided by literally length, you'd wind up with it being turned down so much that it's not even useful. So let's find out. What strikes my attention here is that I've got it doing a crossover. That's going to make a stereo effect. We'll find out what that does. I could also remove the crossover, at which point if we had this running on a stereo thing with a sound like in left, you'd have the bright ambience effect also happening only in the left, and then it would continue to feedback only in the left. So it could be made into a artificially dual mono, but it doesn't have to be. And what I've got right now is one where it's doing the cross coupling. Let's see what we get. Let's see what that sounds like. And we haven't even put in the downsampling, but hopefully that'll be pretty quick because I'm trying to do a modular approach where some of this code works in predictable ways. Back we go. So here's BrightAmbience3. We'll make the feedback go away. Maximum length. Ah, we're getting a high frequency ring. That high frequency squeal is what this is doing. So instead of getting a useful echo effect out of that, we just get a squeal. And that's probably why it's doing what it's doing. That does also suggest that there is no useful setting for that. Like, I might as well have had the square root thing be feedback is always 0. Although we can test that further. Like, check this out. Start is maximum length. This is still normal. As soon as we start including this, we're getting a wild additional effect going on. In fact, that's super weird. And we can make it go away by turning down the feedback. I think what's happening is the cross modulation might be having an undesirable effect. Because what's happening is we're taking the stuff that is, and this is where we get into the DSP stuff. Like when you're trying things like this, you try to figure out why it is doing what it is doing. It's doing this. So you're hearing the initial echo, and then it's going darker. And that's because it's running the audio out of this initial effect back into the input again. So we're just doing it over and over. See, that's not half bad. But it starts having this effect. Quite an effect, I will add. It's bringing out these extreme low frequencies, and the high frequencies are getting ugly. And they're probably distorting your guys' audio. And when I do really long lengths, at this point I can't even hear a feedback anymore, just the high frequency stuff. So the next thing to try is what would happen if I didn't have it cross-modulating. Because the cross-modulating is not saving me from high-frequency feedback. And high-frequency feedback I don't want. Although there is one further thing that I can do, which is average that feedback thing. Let's jump in and reverse these. L and R. Quick swap. Let's see what we get. Because ideally I'd like to make it so that I can have a sustaining thing going on there, but it might not cooperate. It might not be giving me that. Back over to this. We're getting some weird nastiness here. My woofers are shaking like crazy. And then with none of that effect, all we're getting is purely feeding back behavior. So yeah, the whole feedback behavior of this is interesting. And then as we sustain it a little more, we have that feedback note going on. But we never get the tone of our bright ambience to continue in the way that we wanted. This is with no feedback, and then we add the feedback and we never get a more continuous blend of this. All we ever get is that ringing noise. And that's going to be why I didn't have that going on. So let's start trying to solve that. This is the heart of DSP, is figuring out how to make it do what I wanted and expected it to do. Firstly, let's try some averaging. Temp L and temp R, so we'll call it previous L and previous R that we're working with. In a way, I'm just doing that to be annoying. I know that people don't like using the long doubles, but I am doing them anyway. In fact, we can use this as a way to get heightened feedback to play with. Yeah, that would have been 41K, I think. Doing this, I can both get a softened effect and also a gain boost. So now I can get feedback no matter what I'm doing. And you can see the rest of it is still the same, but this is going to give me twice as much loud. And it's also going to give me a softening in the high frequencies because that's now being blurred. As far as the warm colors, I'm changing the lighting and stuff around. No new LUT. The LUT is camera based, and it's based on trying to make the sensors match color chips that I had. But yeah. There's my preval and prev-R. Another reason that I'm doing the long doubles is because this stuff is being done using those, so I'm kind of just If you're assigning a long double to a long double, that's a little more direct than if it has to cast it to something else. Anyway, let's play with this new thing. This is now going to go into some feedback, so I'm going to turn it down a couple of dB. The question is, how much? Oh, hello. Are we working or are we not working? Play, please. Oh, I know what happened. Can you guess what happened? Why could this be suddenly not working? Like everything crashes and dies. What could be causing that? See how we've got this? See how we're using this in a calculation? Well, we instantiated it as a variable, but look up here. We never zeroed it out. That would do it. That's where some weird bugs can happen, and we just saw one right now. I have to do... I have to tell it that those are numbers and they are 0, because they could have been anything, and apparently what it did, it tried to run the program, and the first time it saw that variable, it was going dum-de-dum-de-dum, I know what to do. Oh, look, preval plus temp-L. And there was some value in there that was so insane that the program just fell over, confused, and didn't know what to do. It didn't even play. You got to instantiate variables. Very important. And it never got to this point where if it had gotten past one cycle, it would have been off and running. But in this case, it had not, which is useful because if it just happened to have something in that variable that was acceptable as a number, it might have made a little sputtering noise at the very beginning and then been fine. But somebody else's computer might have done what mine just did, which is hit that point and just straight up stop. I wouldn't have guessed that that would happen, and it sure did. My guess is now it's going to be fine, but we'll see. Why did I choose to downsample and reverb effects instead of adjusting the delay times? Because to run at 192K would involve 4 times the delay buffer for a whole pile of delay buffers. It is far too much to ask, and I can't allocate that much memory just in case somebody might be running at 192K. Now let's see, do we work now? Yes, we do. I hear feedback. But I could also hear something that sounded like sustain. It also sounds like some kind of angle grinder. Let's make length be shorter. Remember how I said it was twice as loud this time? That's what that does. We now have infinite reverb in a big way. And this is what the new feedback parameter sounds and feels like at some of the settings. Running a little faster. It's very weird what we've got here. It's going into a low frequency rumble, which I'm honestly not sure where that's coming from. Yeah, this is kind of gruesome, honestly. I have something that I would be interested to try. I'm wondering whether I can flip the phase and get something useful out of that. If I flip the phase, what that means is rather than this being feedback A, and the way this works is it's containing what it already had. Well, hang on a second though. Maybe this is my problem. Feedback A, see here's, yeah, okay, I'm starting to see where something is happening. Do you see where the bug could be on this? Do you see what's happening with feedback A? Feedback A is a value that continues through the length of the reverb, and I can't seem to get it to work in such a way that if I crank the feedback length up, it continues pumping stuff through the reverb in such a way that it continues onwards indefinitely. Well, feedback A is also working as a IIR filter. My question is, why was I doing this? Because as you can see, like see 1.0 minus feedback amount plus minus feedback amount, this is supposed to be the loudness of the output of the reverb alone, going back into the input of the reverb alone, but that's not really what's happening here. What's happening here is we've got some of that, sure enough. In fact, if we turn it up, we get quite a lot of it, but we also get the IIR filter. So if it's not at full crank, it is continually adding to the feedback what the feedback already is. It's making an IIR filter out of what is supposed to be just a feeding back into the input of the reverb again. And so when we have like a small feedback amount in here, and see this is also taking place here as well. Feedback amount is coming there. I don't think I need this to be an IIR filter. This is changing the tone of that, but I don't think I need anything nearly as complicated as this. Instead, and we've also got this nonsense going on as well. How about maybe we simplify all of this greatly? Because what I wanted was to be able to just sustain things and also get my slightly darkened effect out of here. And you can probably see, let's move this over. L count equals input sample plus, and this is the whole feedback part, but see where this, it's a sine value, so we're distorting it. If we take this out, we're no longer distorting it. We are scaling it by this, feedback square root length plus 1. If we didn't do that, then we're not turning it down further. And then it's times feedback amount again, where it's already being applied here. All of this is too complicated. I don't know what I was thinking, I only know that it didn't work. We're going to strip all that stuff out, and let's see what we get. Firstly, this is the raw feedback behavior now. And secondly, if we take out this IIR filter stuff, like so, we won't be needing this layer of parentheses either. See how much simpler that is? This should do a slightly darkened and potentially a whole bunch of extra gain direct feedback of what only the output of it is. It's much simpler, but it should also work. Let's give that a try. This is a fun thing to do before actually doing any of the undersampling part. But then the debugging was needed. I'm not exactly sure what I had in mind. I only know that I did not like it when I revisited it. So, what did we get? Remember, we still have our single sample averaging. So everything is being darkened slightly. And our length is going to be much the same. Still working. Wow, that was impressive. Okay, we don't need nearly as much feedback as that. Holy crap. Let's hear what it sounds like more delicately than that. Oh, no, it was not happy. It blowed up. It blowed up real good. Why did it do that? First of all, let's do the divided by square root length again, because that's clearly blowing it up. We're fine with going back to what we had before. We're not even going to do temp L anymore. So this is probably still going to blow up, but not as aggressively. I want to see what it does. This is probably fine. And our maximum feedback amount. Let's just run it and see what happens. Let's not overthink it. Although I will say one thing about this is our power factor doesn't need to be there. Hey, let's do a power factor of 1. Quickest way to disable that. What that was doing was inverting the power factor. So with that control, if it was just 0 to 1 and I was using the power factor of it, what would happen is you do like power factor of 2 and we'd have tiny numbers in the beginning going to much larger numbers in the end. But since we were doing this like power factor, the end result is 1 minus the power factor of 1 minus the thing. That's inverting it so that what's going to happen is the number will jump up much more at the beginning and then slowly approach 1. That it's basically just doing a different taper on the control. But we're going to ignore it for the moment because it's so responsive already. I'm just looking at chat, don't mind me. Let's see what new hell we have here. This should be adapting to the length of the sustain now. Oh, no, it's kind of freaking out. I'm getting some extra energy in here somewhere. I'm not exactly sure what's happening, but I have a tendency to blow up here. Yeah, if the DC drifts in a direction, it can just go out of control. So here's a question. Should I be subtracting that? Let's find out. Seeing as it blows up and all, if each time it goes around I'm subtracting rather than adding, in theory that might take away from the DC runaway. because it'll always kind of be resisting what it's trying to do each step of the way. Instead of adding some kind of bias, it'll be removing it again. But I'm not sure, so let's find out whether it worked. Nope, we're still blowing up. It went away faster though. Oh, I hear a feedback note, and there we have the DC feedback. So hear the feedback building up, and yep, one of the channels went out of control. And that's the thunder. Yeah, so this is really interesting. I'm really wondering what is causing this runaway. As you can see, it's doing a major runaway anytime I have the feedback going. It's just blowing up. You can probably see that on the meters. And that is because DC energy is getting into this feedback loop. Even at this fairly short run. We get a shorter run. That's a little closer to what I'd like to hear out of it. I bet if I increase this, we're going to end up with a at some point I'll end up with infinite feedback, which will also be giving me DC. I don't know why DC, but I'll be getting DC out of it. So we're not quite at feedback yet, but you can kind of hear it going. The pre-delay is because start is this late. I can make that be shorter. I don't know if that's going to change anything. And we probably don't need to have this much area in the really fast delays. So adding length should make it increase into the zone where we're starting to get full-on feedback again. And there we go. It's out of control. Pretty much, yeah. The challenge here is that as I increase length, it will straight up blow up. It'll become completely out of control. I'm also curious about something else. I'm going to quickly run the plugin and then look at the result. And then not save what I made, because I'm not going to want to save this. But let's see what that waveform looks like. So there's my echoes, and you can plainly see that you've got like this noise. Here's an echo. This is clearly inverted, and this is down, up, down, up. It's fading off. But what is happening to this shape as it goes into its echoing? I don't think that's actually telling me anything useful. So, time to explore a little bit longer. We've got length here, setting this stuff up. Feedback amount is just as well not, might as well keep it simple at this point. The amount of feedback that we can put in is much less than 1, and that's partly because we're averaging. So feedback amount is always going to, in fact, if we're averaging, we know that it's always going to be 0.5 or less. So getting infinite feedbacks in there. Now, in a former one, we had, oh, hello, here's a thought. Input sample equals temp L divided by square root of length. What if we just divided it by length? Can we have a length of 0? No, because it's plus 1. So it's int power this times 47, and if it's 0, then we add 1, and it becomes a length of 1. So all these are always going to be at least 1. Let's try it and find out, because one thing for sure is that if it's building up any energy this way, you did actually have to divide by length to make it so that if there's a DC thing, what's going on basically here is that this particular reverb algorithm, it's capable of hanging on to DC and putting it across in an emphasized way, which is not the case. Enough talking. Let me just run it. Let's see what it does. We've just made 2 changes. Having made 2 changes, this is now our infinite sustain, except for it's not. Short length, that's a nice clean echo. Then we start losing it because our lowest frequencies over the total length of the decay this is going to be able to prevent it. We're essentially dividing the amount of energy in the sound by the total length of the decay. So if we have a really long decay, it will emphasize the lowest frequencies enormously. But we start losing these highs, which is why the square root thing was a thing. So that's now our loudest output. The square root thing was giving us an output that related to the square root thing was giving us an output that related to how loud the return of the reverb, the ambience, seemed. But as far as feedback is concerned, what we've got inside this is actually a load of low frequencies available. Like if we were to feed it back 100%, which we're doing right now, that high frequency stuff just kind of fades out. It's just out of the picture. Which raises a possibility. What if we were to throw an IIR filter on the reverb return and use it to cut out the bass? We might be able to get more amplitude out of this and still be able to have feedback, because the deal with the feedback is when we have a short length, 100% feedback. We can get into the dub delay thing by using the feedback divided by the length, and we're losing more and more of the loudness but one of the things that's happening is the longer delay we've got, the more it's going to bring lows in. So here's the thing, and if we can get this to work, we can do the undersampling thing and it'll get it to work at all the sample rates. Probably. Still need to test it on like 48K equivalents. But this is how we get something that sounds right on the output. Might even be able to exaggerate that further. Let's see what we get. We'll leave the feedback amount alone for the moment. Hang on, do I have a... Hello. Cube root. So do this even more so. That will attenuate things even less. And feedback amount will definitely blow up now, so we'll leave that off. Let's hear what our loudness level sounds like now. Because the square root thing did tend to cut back on the loudness more than a bit. All right, feedback 0. Length. Okay, I'm liking this. That's a nice beefy thump too. It's going to have all kinds of uses. And remember, this is at 96K. I can get more delay out of this once I do the undersampling. And feedback will blow up immediately. So I think using the cube root instead of the square root is better here. But this does not solve the feedback problem, because our low frequency ring there is a factor of Let's see now. So I do have a feedback parameter sitting around here, but there is now no real well, no, there is. I need to save it between samples. The question is, can I make it into a high-pass filter while still using it as a feedback? No. I could make it into a low-pass filter, and I was, but I can't make it into a high-pass filter. Although we're subtracting it, but it needs to be a low-pass filter against itself. So let's put this back to what it was. We have now made input sample L be something, and we need to define something else. Namely, and of course instantiate those as well. And I'm going to bounce back to probably channel for another point on that. Presto changeo a low-pass filter, because the thing is, we implement this in a different way. By adding it and then subtracting it from this. So bug. So what we're doing here is we're keeping this low-pass filter, because that's what this is. It's smoothing out the result by taking what it already had and then adding a little bit of the new signal coming in, which will slow the response. And if we're feeding DC in, it'll rapidly converge on the DC and keep it there. And then we're using our feedback by adding the original sound, which could have contained DC, with whatever is in the high pass. We're subtracting that. So if it built up a bunch of DC, then we would wind up having that taken out. And then we're also including that in this averaging filter. The previous L becomes the same thing over again. So it's two instances of subtracts, but it makes sense. Or we could have previous L plus input sample L minus high pass L times 2. That'd work too. But for now, this is probably functional, so let's see what we've got. Still no undersampling, by the way, because this is far more interesting. Or at least feeds back and blows up far more. Okay, we got our ring. Oh yeah, that's nasty. Wow, that hurt. 147 dB. Thanks, programming. Wow, negative infinity dB. Okay, we've had enough fun with that at the moment. While my speakers still survive, let's stop. Part of that might have been because I changed these. Probably not all of it, though. The high pass thingy is not doing exactly what I thought. In fact, I'm getting these high frequency rings so much that I'm not sure the averaging is helping at all. Let's not bother with that. We'll take out that averaging and keep only the high passing. If we wanted to get really fancy, we could throw in a biquad and have it be a mid-range, and that would work. I have no idea what frequency it would be. Here's another frequency. If we are specifically wanting to avoid the deep bass running out of control, we can have it be a very gentle filter indeed. Bottom line is these are simply low-pass filters, and they're being applied by producing them and then subtracting them from the original. So you generate the low-pass filter and then you take it back out again and you've got the high-pass filter. End result being a high-pass filter. Let's see what that made. Because, yeah, like I said, I was trying to moderate the high frequency stuff there, but the simple averaging wasn't really doing that much of it. Oh, no, we've got nasty feedback. I think that might have been supersonic. I didn't see the woofers doing anything weird. Let's make it do it again and see what it does. Nasty feedback. I don't see the woofers doing anything. Turning the volume down. Let's find out. First of all, let's make sure that it reproduces. That's some feedback. There we go, blew up. Now, apply and close, and let's look at what the waveform did, because it went into super distortion, and there it is. Oh, and it's not going to be able to go any further here. Let me move this over. This is what it's doing. It is now doing such high volumes that it's just straight up going to die. It's never going to make it to the end. I wonder if I can command period stop it. Nope, I'm going to have to quit or force quit it. That is a high frequency ring. If it was DC, it would be only on one side. Oh, hey, it stopped. I think. Let's investigate. Or it's something else. Because if I expand outwards, this no longer looks like... I don't think that's where samples are. No, that is. See, this is how far our samples are spaced from each other. And we are straight up doing like between infinity and negative infinity here. And as it approached that, we got an increasing amount of high frequency ring. And then it just kept building up because that's what the feedback was doing. So the averaging might have actually helped a little bit. And stuff like this is all purely high frequency ring. By the way, this drawing of a waveform isn't necessarily very accurate. It's behaving as if it's a perfect frequency. And to some extent, since this is literally at the Nyquist frequency, the digital to analog converter was filtering it out, thankfully. Otherwise, my tweeters would be just toast. They would be gone. Because that is as loud as you can get at the Nyquist frequency, or more so. Enough of this. Definitely don't save. So, yeah. So the question now becomes, do I want to sustain this so badly that I want to bring a bandpass filter in here? Because I could. Might be kind of fun. I think I'm going to run a little extra today because I'm not sure how many people want to stick around for it, but I keep having new things to try here, and here's one of them. Where can I find a most recently arrived at bandpass filter? I know I can go to just straight up biquads, but I'm wondering whether I can go to something like Focus or whatever, where I worked with it more recently. Because stuff like this, I know a bandpass filter lives in here. See, I called it figure. So rather than these things, why do I have a feedback C too? That I can't say as I entirely understand. So neither of those things were any use, so we're going to not use them. And we're going to steal the code from out of figure, in part because that was a mid-range centric resonant peak that could be widened arbitrarily. And I'm wondering to what point can I widen this before it starts giving me problems. It's fun to find out. Oh, and I have a mistake here. I shouldn't be looking at the AU for that. I should be looking at the VST. Why? Because this is a stereo plugin. And the VSTs are stereo plugins. Oh, but this is not implemented in the way that I've got biquads in stereo implemented. That's funny. Okay, well, never mind. Well, no, I do want focus though. Let's just go with that. Feels kind of wrong. Feels kind of like this is not right, but whatever. Can't be too fussy. Also, I bet feedback C never gets used for anything. We'll take it away and see whether everything crashes. And I bet that's what's in figure. I mean focus. But it wouldn't be there because this isn't the AU. Yep. That's how that one works. Scooch this over where I can see it and you can't. And we're going to grab this as just a big chunk. And plunk it down in here after the other code so that I can tell it apart. And take out some of these things. And parameter 5. We're not using this. So this now is all biquad oriented stuff. It's 2 different biquad filters. And this is them. So our input sample is still fine, but we're going to want to do something with this. Namely, we want to do something with these feedbacks. Because we're not assigning input sample again until we hit this point. These points are the points where we're making input sample be a bandpass, but it's this that we want to send to the feedback. So we'll grab that and put it in here. Grab this and put it in here. And then instead of this input sample stuff like this and so on, times feedback amount, we're sticking this, because that's the output of the bandpass each time. We're using it over and over again, like we're starting it here and then doing it again for the other channel. But doing this now means we just made 2 biquad filters, and they're being run on input sample, which is our like scaled down in volume output for the reverb effect. It's strictly the reverb effect, and it's chilled out a little bit in volume, but not all that much. And then we're band passing it, and our control 5 is determining how wide of a band pass we have. So in theory, if we make it real narrow, then what we're going to get is a reverb effect that cuts back the width of the frequency range completely. No more DC, no more super high frequencies. And if we can make those stop, it should work. Do we have our... In fact, we might even dare to do positive feedback instead of negative feedback. See what we get. Because we're running everything through a filter anyway, so... And our get sample rate needs to be changed because that was from the VST, and the VST code doesn't use that formulation for it. See, this is capitalized and this is not. Going back and forth between the two means you have to change that. So it seems possible that this will work. Let's find out. I'm going to outlast y'all. It's going to dwindle away until there's nobody left. Just me. So feedback, not all that much. 5th, this is the width of our filter. It can go from very wide to very narrow. Let's see what we've got. So here's our echoiness. That was definitely feedback, but it took it a while. If we move it all the way over to 0, the bandpass is so wide that it's still letting low frequencies through, and it does this. Actually, I gotta turn it back up again. There's a pretty good dub echo at this point. Our trouble comes when we go for longer lengths. Yeah, see, that was subsonics. So what I'm now questioning is whether I can tie this to the length control. Starting to look a little bit like maybe I can. Whoop. That's a little out of control. Let's see what we get if we do try that. So length parameter 2. So also will be that. Not only that, let us make the fixed frequency more along the lines of 1K. Because it'll be wide enough anyway for most things, but I'm losing the low frequency feedback faster than I'm losing the high frequency stuff. So I'll shift the whole thing down to take out more of the highs as we go. So now this biquad is tied to the length control. Let's see what strange misbehavior we get now. Michael Norris does spectral plugins. I don't have any of those. I would go for like my reverb things for that sort of thing. BrightAmbience3. So here we are. We have our lengthen thing. We're using it as a dub delay. We can definitely lose it with this. High frequencies and low frequencies both at the same time. Interesting. So here's the question then. What if we multiplied the length? And by that, what I mean is, because remember this parameter 2, it is a we got multiple power factors in here. All this could be adjusted. Firstly, let's not scale it back so damn fast. How about not having that initial behavior be a power factor at all? We can make this scale up pretty good. So it goes down to a very small amount, but we could make it be much bigger than this. We've got a straight up param 2 times 2, so the middle part is going to be 0.5. You can multiply that by itself as many times as you want and it won't matter, but we can have it continue to get larger, and the larger it is, since this is the resonance control, the tighter the bandpass will be. So what if we have times 3? We've just changed that a lot. Let's see what we get. This is very much that sort of right brain scrambling to try stuff and see what they do. And what I recognized there was the parameter was scaling things to be much smaller at small length values. Let's see now. I still have that at like infinite reverb here. Maybe not really infinite, but so in theory, as I continue to amplify this, Yeah, it's starting to not. We're focusing in on that note so much that we're no longer getting the high or low frequency feedback. That's 1K right there. I can widen, I can tighten up that notch filter to the point where nothing's feeding back anymore. And widen it a bit to do this. So the next thing to experiment with, and this is kind of the heart of what your DSP madness gets into, is that we're trying these things with a fixed intention towards getting a result. We're working towards a sound rather than just kind of abstractions and juggling like feedback and all kinds of messy stuff like that. So what was happening was we changed the way we got this number, and we changed it by making it become much larger at higher settings of parameter 2, which is length. The tighter we can make that bandpass filter, the less it's going to feed back in the super lows and highs. That's a value of 3. So if we temporarily made another thing like get parameter param 2, but instead 5 again. And we know that we tighten it up so much with the factor of 3 that it's enough. So now we can make that go from 3 to something smaller. So we put it in here. And I'm also wondering whether we need this power factor. Because what that's doing is it's making it wider for middle settings of the control. Oh, no, but we do need it though because we need it to ramp up the extreme settings more. That's what we need that for. It's also making the wide settings wider. So we're going to get a W kind of effect out of it. We could even increase this, but not worried about that at the moment. Can kind of try one thing at a time. Not really, but sort of. So there's a new change. I don't know if I need to change the frequency. I guess that will depend upon where I set the out of controlness. And feedback amount has predictably been giving us ultimate sustain at literally 0.5. So we're going to change this to 0.25 so we can turn feedback all the way up to 1. People will be expected to not always do that. So back into the breach. This has proved to be most of the work today. It's this feedbacky stuff on this crazy effect. But it never did work. I was never able to get it to work before. So this is what it takes, apparently, to make this work. Here's our feedback. Here's our W effect. It's not really quite infinite sustain, but I could probably tweak that. And we have a kind of mid-range feedback, but it's not high or low frequency. And again, a kind of a mid-range effect. So what happens now is if I reduce this control, what's going to happen is that long range stuff, the long length, is going to widen slightly. And I'm going to see what it does. Giving me a wide range of different noises. Full length. Well, one thing about it, I'm getting a certain body out of this. There's a certain texture, which, if I tighten it up, this is smaller. And this is a lot wider. So one thing I could do is tie in the feedback as well. So if we have less feedback, it automatically widens out. Yeah, let's see what that's like, because I do have that now. So let's see, where were we with that? So tightening is get parameter 5. And I've already got this parameter 2 multiplied by tightening, but if tightening was instead parameter 3, this is where it gets really complicated. Here's our feedback amount. And the smaller this gets, the wider it is. So basically, if this gets reduced to small amounts, that means that it's full bandwidth again. So we now have that implemented. If get parameter 5 is 1, then we have this set to sort of its full crank. If we multiplied this by 2, then we have that adjusted as well. Let's see what we get. What ways does this, the elaborate conglomeration of all this stuff going together is what makes it kind of interesting. Because I was hearing a interesting and useful widening on the full crank at full sustain. What do we got? That's feedback. So that's very dry, but that's a little thicker. So here's the strange land that we have been taken to. A land where length produces unpleasant high-frequency feedbacks in the mid-range. That's pretty dubby. And of course, if we don't have feedback cranked up all the way, it's not quite as aggressive with it. So if we played with fifth by making it smaller, that's going to make the bandpass wider. That's a little too much. This is definitely becoming a something. Well, I mean, this is doing pre-delay. We're definitely not getting as much crazy feedback at these shorter lengths. I mean, they're functional, but they're not too out of control, whereas down here, feedback city. So why would that be happening? Well, our feedback amount is working like this, and it's relative to bringing it in here. It's also scaled down substantially. And if we were to put that stuff back, then rather than tightening be on this curve, oh, hang on, maybe I don't want it to be, it would be automatically multiplied by 0.25. So if I was to use this for that, then that's 1/4 as much as it was, so tightening would have to be 4 times as much, so times 8. This exaggerates the amount of param 2 in here. And if I have it cranked up all the way, get param 5 is at a level of 1, so we can take it out. So tightening becomes feedback amount times 8. To get it back into the zone. And this resonance factor becomes the length, which interestingly enough is going from like 1 to 488. So already then, but we're not using that factor. Instead, we are using get param 2. But we're not scaling it. We're not doing a power factor on that. So we might try using the raw length figure, and instead of multiplying all this stuff so much, dividing it instead. So tightening goes away, so we're going to want 8 times as much of however much this is. And length instead of parameter 2 because it's scaled. And then we're also going to want to divide it, so times, let's divide it by 10 for now. So that to the power of itself. We don't need this any longer. And now let's see what we've got. We just changed a whole bunch of stuff. Oh. We can find that number very easily by putting it on a slider. So now what's going to happen is our resonance width is not any longer going to be, we're trying to get the curve of it so that it will give us useful feedback on the really short little delays and the narrow windows, and then the large windows expand outwards but are still not too out of control. And this might be in the zone depending upon how I set parameter 5, which is going to start out at about 0.1 and will almost certainly be even smaller than that. Build. This is starting to go so fast, I'm confusing myself. Onwards. And better not be that big of a number. Now what do we got? Okay, that's full feedback, all right. So far, so good. Okay. This is all kind of coming together. It all depends upon where this is set. I believe if I turn this up, I'll start getting more feedback. Unless I have it backwards. Let's see whether turning it down gets me more feedback. Aha, okay. I had it backwards. And I'll tell you why. As I turn this up, I'm using more of the length value. The length value is in the hundreds rather than in the ones or tens. So more means more control of the feedback. As we can plainly hear. And of course, we don't have to have the feedback on literally one. We'd ideally like to have it making kind of squealing feedback noises at every position of length here. It's not, but ideally we want something along those lines. Like there, that's definite feedback here. Not so much there. But you can kind of hear it floating around. And I can hear a note in there. So let's play with this. We get very weird effects this way. This is like an insane flanger. And I can think of one thing that I could do, which is add just a little more of this. This is our minimum amount, and it always needs to be something, but our narrowest bandwidth is still allowing for some effects here that aren't entirely what I would want. If we add this sort of generalized offset, this is our resonance. So 0.7 is a Butterworth filter, which is about a 6 dB bandpass. That's already too narrow, but it doesn't have to be nearly as tiny as this. I'm going to go from 0.001 to 0.1 and see whether that tightens up these medium ranges a little bit. The high ranges are going to be about the same because it's a simple add onto everything else. And I suspect nothing is going to make this a nice continuous sustain. That's for reverbs. This is more along the lines of the dubby effect echo kind of thing. And of course, this is all being run at a very high sample rate and everything is going to be voiced a little bit differently when we undersample it. Oh, it tweets. Cool. Hello. Real dubby. That's broad enough to have some lows in there. Okay, I'm liking where this is going. And that's kind of nice and wide. Remember, with no feedback, we get this. But if we fill it up a little bit with some feedback again, we have some of those notes popping out, but also a little bit more texture. Cool. Hey, metallic effects. And that is boosting the bass in a totally weird way. I'm also liking how much I can move these around while playing. thing, because this is starting to look feasible. Although I do need to write down that number. Let's go back. Because I think that's about the number I want for that. Effects, rates and effects. 0.037 is where fifth is supposed to live. So that should hold us. The settings were giving me the demented W effects I was looking for, and the only thing that remains is undersampling. At which point all of this is going to sound very different to you, because this has all been in speeded up mode. This is not the tone it's supposed to have. Let's see whether we can finish with a bang. I don't need focus here anymore. Can we be using the other one? Oh, it's in VST land. I'd rather look at AU land for this. Going to be about the same for those other values, I think. Yeah. Last reference cycle. That's going to be the same. Here's our instantiation. It's going to live here. This gets tucked in just under overall scale, like that. Then this comes in before BrightAmbience starts doing its thing. So before this and this, and I think before these temps. Yeah, sounds about right. And then on the output of it, this is where we live. And our filtering is going to be very helpful. So copy that over, put it in here, and our dry wet should be fine. That was never outside the undersampling, or not outside the undersampling. There's the output of Air2's algorithms. Let's see to it that everything is lined up properly. Format, re-indent, and let's see if it still builds. Interesting. Okay. Oh, I know what. I do actually want the other one, don't I? Oops. Okay. That's a fairly simple change. Goodbye, Air 2. This part of your stuff does need to be coming from here. I'm moving as fast as I can at this stage. You can just move over, sir. Oh, I do have L and R. That is what I want. So where's our instantiation? Did that work right? Not exactly. We're going to want that formulation because we have two sets of them. And then we're going to dive in here. Not in here, in somewhere else. And we're going to dive in, not there either, in here. That's going to be the same. That's going to be the same. But this is the bit that we want to take. Meaning that this is where it starts getting replaced. And it goes down to here, where it says case 1, break, no further averaging. Build. Take, use, and there we go. BrightAmbience3 undersampled with full feedback. So we can now get sustained this long at all sample rates. We can get this sort of droney quality. Whoa, something happened. Okay, I think maybe a little debugging might be in order. That was intense. Did you see how high that went? 248 dB. Wow. Hard to tell what's going on there. It does not like start being set to 0 when I do that. On the other hand, this is awesome. Oh, I think I see what's going on. Oh my God. Yeah, doesn't like that. Yeah, they're surviving. The amplifiers they're being driven with aren't all that powerful, and the loudness of this isn't that overwhelming. I should maybe put in some kind of like extreme mayhem clip factor. That seems like that might be a good idea. Just on the very output, a limitation for, oh yeah, no, I would be automatically muted by now. Although the algorithm seems to be holding itself together, all things considered. That's impressive. That, or I could clip the feedback. That might be an even better idea. Yeah. Let's start fooling with some of that stuff. Let's see if we can clip some of these things. Yeah, because I'm like smelling fire now. Not really, but yeah. And what was going on was it could blow up into really crazy feedback by having start be too small. Also, I don't think I need feedback amount to have this complicated parameter. I think it's just straight up param3. We don't need to do the elaborate, because at this point the large settings on feedback are quite large enough. I'm no longer having a problem getting feedback to engage, so we're not going to taper it that way. Could even be dialing it back by start. Trying to figure out whether I need to also scale this back by what parameter 1 is doing. Oof. First things first, I have a feedback parameter in here that is potentially really problematic. So let's see whether we can clip that somehow. That's probably what I had going on in the other one. Let's see whether we could do something even weirder. Shall we? Want to do something really weird? This can come from the old version of the program. We simply do this. The output can never be larger than 1 or less than -1. But if it goes completely insane again, it can go into wave folding. Now let's have ugly time with this. I think that was never actually about a neat controllable distortion factor. I think that was always about catching complete insanity and turning it into something else. Speaking of complete insanity, let's go make some. Okay, maximum of 12 dB. That's peaking out more like 6 dB. There's a particular zone in here that seems to be so that's interesting. So what's the deal with this zone? This is weird. We got a real sensitive area right there. Oh hey, it can become a drone. Maybe I should just restrict where these things can be set. Like the only purpose of start being this high is kind of to do that. So, curiouser and curiouser. I remember being a little concerned about start, that it didn't need to have this big taper on it. So now what I'm wondering is whether I can design start to not cut back that much. So first things first, let's get rid of this power factor. Then, what happens if instead of having this be 47 plus 1, you have 400 plus 88. All right, see you later, Bo. I'll probably be finished with this pretty soon. This is down to the final sort of details rather than major concerns of revising everything. Because I was definitely a little concerned about the that start setting not being useful. Like all the useful settings were on the right side. Like if we have maximum length, it makes no difference anymore anyway. So if we have start set like this with the pre-built-in sample thing, at any sample rate, this is going to be our fastest echo. And if we go faster than this, it turns into crazy blowing up feedback. Okay, that's pretty crazy. Time melting, time melting. Again, this is all at maximum feedback. You don't have to use this much feedback. And let's go back to that again. Okay, 18 dB. So just for fun, let's find out what happens if we straight up put a sine calculation on the end of this as well. Feedback amount. Oh, hello. This is a better place to do this. Check this out. Because it's being divided already, so what's going to happen here is feedback A and feedback B are still going to be restricted, but they'll wavefold easier. we'll still end up with the same basic result, but feedback A and feedback B are going to be crazier when they're happening. So let's see what we get, because that was definitely a bit loud. Yep, 4 dB. Ah, yes. We got all our weird feedbacks going on, but it's not peaking out in double-digit overloads anymore. And we can still dial it back to normal bright ambience, which was originally what people would be expecting to get if they were downloading this and using it. This is all we originally had. So the only thing I wonder is whether it'll be better with cross-modulation. Let's quickly go and find out. Seeing as this type of effect is an insane, spacey, crazy effect, so maybe the ping-ponging inherent in cross-modulation will help it. If it does, we're done. It's ready to go. Because that's only a factor of the feedback anyway. Alrighty, let's see. How does this feel? You can't actually hear the stereo. It's actually not as out of control as it was. But it's still got the inherent sort of vibe of that. Yeah, I gotta say, I'm kind of digging this. And on that note, I will bid you folks good day for today. You should have this plugin next Sunday. Hope you like it. Talk to you later. Bye-bye.